Okay, so we can evaluate the difference quotient for this function. Do we have enough room for this? So here's our function. F of x equals x squared minus 2x minus 3. So let's do that. Let's evaluate the difference quotient. For f of x equals x squared minus 2x. I just want to make sure I have that right. Yep, minus 2x minus 3. All right. So do exactly what the difference quotient tells you to do. So we're trying to find f of x plus h, and then minus f of x. Then it's going to be all over h. And you're going to want to simplify that as much as possible. So when we do this, let's color code it a little bit. Let's find f of x plus h. Now f of x plus h is you're going to just evaluate this function here, but wherever there's an x, you're going to replace it with x plus h. So f of x plus h is going to be x plus h squared minus 2 times, and instead of x, we're going to have x plus h minus 3. So that part is the f of x plus h part of it. All that is f of x plus h. And then it's going to be minus, let's do this one in red, so minus f of x. So minus, and I'm going to throw parentheses around this because we're subtracting the entire function, minus f of x. So that's going to be x squared minus 2x minus 3. All over, so make sure you draw that under the whole thing, all over h. The rest of this is just simplifying, right? So we've got two things. The orange part is the f of x plus h. The red part is the f of x, right? So f of x plus h minus f of x. We're just going to sort of crank out, do all the algebra and collect like terms. So we end up with x squared. Remember, you have to FOIL this. So this is going to be x squared plus 2xh plus h squared. Distribute that minus 2, so that's going to be minus 2x minus 2h, and then we still have that minus 3. Probably should have done that in orange so you could see where all those pieces are coming from. But then here on the right, we got to subtract this, so we're going to distribute the minus sign, so it's going to be minus x squared minus a negative 2x, which is going to make it a positive 2x, and then minus a negative 3, which is going to make it a plus 3. And then that whole thing is going to be over h. So the very last part of this is simplifying. So you're looking for like terms in the numerator. And you'll notice it looks pretty complicated, but look what's going to happen. We've got x squared here, right? And we've got minus x squared there. Those add to 0. We have 2xh. There's no other xh terms, so that's going to be left over. We got h squared. No other h squared terms in there, so we got 2xh plus h squared so far left over in the numerator. Minus 2x, we're looking for like terms. We get a plus 2x. Those add to 0. We have a minus 2h. Right? There were no other h's terms. And then we have a minus 3 and a plus 3, which again adds to 0. So that's our numerator, 2xh plus h squared minus 2h all over h. And since they all have an h in it, we can factor that out as a common factor. So I'm going to say h times, in parentheses, 2x plus h minus 2, close parentheses, all over h equals, right, that'll reduce, the h is reduced to just 1, and you end up with, that's our composed function. I'm sorry, that's our difference quotient. So the difference quotient for this function is 2x plus h minus 2. That's a really useful, and you'll see this a lot, especially when you first start Calculus 1. You'll see this a lot when they develop when they've developed the derivative.